Hello everyone and welcome to Google Cloud OnBoard. My name is Ify and I'm an instructor for Google Cloud. Today we will be talking about Module 2, Recommendations and Predictions. Of course, at any time during our live sessions, you can ask questions on our platform and our team is standing by to answer them. So let's get started. So we're going to talk about this product recommendations using Cloud SQL and Spark. And then we're going to talk about what is the recommendation systems. All right, so let's begin. So what is a recommendation system? Because why we wanted to talk about recommendation system, that's the majority when we talk about anything machine learning. Yes, it is. And that's at the end what we wanted to get. So let's see. Recommendation system, it is used in many applications, and take our Google's examples. This is the one. So on the right hand side, you can see, we have a smart reply in Gmail that basically give you like a free recommendations. And then there's a possible answers to answer your emails. And that's a super common things, okay? Yeah, because that's very easy because sometimes some email just coming up said, are you going to show up with the meeting? You'll say yes or no, and that's it. You actually just need two answers. We give you free, right? And then now you have Google Photo as well, which actually recommends similar pictures to include in an album. That's nice, right? Because in that case, you can easily just put things together and then that's an album and easy for you to share. All right. And another example here, oh my God, this is my one. I mean, I shouldn't get this example here because I'm so hungry. It's just about my lunchtime. So Google Map actually recommends some restaurant, yummy. So based on what you like, instead of just the location, location-wise sounds easy, but what we get, we have the locations, and then if you use those Google Map to actually do some ratings for some of those different places, yes, we actually able to get a little bit more information about what's the kind of food, if you like Italian or you like yakiniku like I like my steak, I like my pasta, pizza, that kind of things. Yeah, maybe you see that's why I'm fat. Okay, so whatever. So now you get the recommendations and then now you can go for it. That's nice. That's a user experience. Your user might not notice you are doing recommendations. They just feel that, there are some nice restaurant just showing up and then they looks amazing. I want to give it a try. Seriously, most of the time they don't think about it, but that's a nice user experience. So I said recommendation system also need to meet the scale. For example, like YouTube. I told you already, that's a lot of things. 400 hours of video uploaded, and then with so many users there waiting to see all those nice videos. Then what do you do? If you wanted to do recommendations, you have to do it fast. So that's hard things to do because you wanted to really to hit them, and then when you upload, for example, something new, you want we, Google, YouTube, to do the recommendation to really to meet. So when there's a new content, we have to make that involve as well. So we said recommendation system require data, a model, and training serving infrastructure. So instead of just the data and the model, you actually need a lot of those infrastructure support. So that's why we have just mentioned a lot of things about our infrastructures. So we said the use case here is recommending housing rental options. So just take this as examples. When you actually need to recommend, for example, a website tells you, there's a house for rent, but what kinds of house? There's a lot of different options. You might have those smaller ones, which is just a room that is going to rent for people that wanted to go for a nice and easy and then not much spending too much money on that. Or if that's for a family, you need a bigger space. Okay, so there's different options. So are you going to do this one? For example, train machine learning model based on rules? I would say no. Why is that? For example, most of the people go for those common rooms. Maybe they're just coming here for work, working abroad like me, or For example, that you have some students, they just wanted to have some limited budget for those renting a house or renting a room. But that might be not the case. Maybe you just want to treat yourself a little bit better. So you might looking for something else. So it's very hard for you to actually define those rules, and those rules will always change, right? So we said, not going to do with the rules. So how would housing recommendation works? So here's how it works. So basically, most of the time what you do, still similar, but based on the true answers coming from your users. What is that? Your users, they have a lot of different kinds, and you might know their profile. You know that they might be student, they might be young, but doesn't matter. You're still going to see and then to put those different users into groups. So basically, first one, you will see who is this user like. So you put users into groups. And then second, you will start to talk about those items, which is those house. So put those house into groups. Is this a good house? All right, so those users coming to the website and then giving out some rating to tell us, oh, they like the house or not. And based on that, we have two kind of things, which is the user and the item, and then we have the relationship. Now we might go into predict. So based on those data, to create a model and then start to predict the ratings, that maybe there are some new items coming out, and then those will be the good ones for some of the group of the user, or they are just look like some other items here, which is also nice, right? So this is the kind of way we can do the recommendations. So we said, interestingly question coming out. How often do you need to compute the predictive ratings? So basically how you're going to do the recommendation, because once you have the predictive rating, then you know what's the ranking, then you're going to recommend it, all right? So where would you save them? That's also one of the good questions here. So let's try to choose the right solutions approach. All right, so first one, how often and where you compute. Basically, compute is one of the things. And here, let's just compute rating once per day. Okay, so in that case, it's a batch. So that's a super common things that we have done before, and then for all the e-commerce websites, actually done that already. So this is an old story, but still nice and easy, and it's good. So the most popular way is actually using Hadoop, which is the open source big data software solutions. And like a long time ago, before Hadoop coming out, people actually just having all those data, which is those rating kind of things in the database. And then they use a processor to bring those data coming from the database to the processor to start to process and then give it to the user. That's how it works before. But once Hadoop coming out to the world, that's kind of, we said there's a wave. That's a second wave because things are changed. Instead of just get the data coming from database to the compute node and then start to process, here in Hadoop, we do data locality. What is that? That basically means because now you have way more data, and then to moving those data, spending so much time when you do the transit in the network, so you're trying to minimize the chance you move the data. So you basically have the same machine having your data and having your compute. So basically, you are not going to move your data when you're actually trying to having those recommendations. So that's Hadoop. So Hadoop, the computing and where you store the data happens at the same place. And that we call data locality. But then now, which is today, we have cloud services. And then we just mentioned you that we have petabit by section bandwidth network. So because of that, we no longer need to have that tightly coupled system, which is storage and compute all together, and which we win some performance because of the data locality. No, we don't need that because right now we have petabit per second, which is by section bandwidth network. So you can easily still put storage and computing separate. And then now brings you something even better because you can shut down your cluster, or you can always choose different kind of things to do those computations. So the rich open source ecosystem for the big data is like this. we have the yellow elephant, which is the first one, which is Hadoop, and then we have the second one, which is Peak. We have Hive, which is a SQL-like, and even Spark, which is something pretty famous. Okay, so those are the different kind of things which is in the open source world, and these are the commonly used ones. All right. So let's just quickly go for a demo because you might know those open source already, you might not, of course. If you don't know, just go and check to see what is that. But basically, these are the most common ones, okay? So just coming back again, the Hadoop, which is the yellow elephant. Peak is one of the scripting language that help you to do scripting language and then leverage the computing power of Hadoop. And then Hive is the one have a SQL-like language, and Spark is something comes a little bit later, but that one supports whole bunch of different needs, which is parallel computing framework, and then also deal with streaming and machine learning as well. So let's do a quick demo about how you're going to get that cluster, and then we're just getting your infrastructure so you can go ahead use those big data open source. So let's see the demo. All right, so here, coming back to our Google Cloud Console, right? Yes, exactly. It's just the Google Cloud Console, and then you see I'm so hungry. There's a hamburger here. That's the icon. All right, so now let's see and get our data prog. Where's my data prog? Here. Okay, so data prog. Now we're going to having a cluster here, and what we're going to do first, of course, creating a cluster. So let's click on it. And then now today, we're going to create a cluster easily, just put the names on it. So, today I'm going to do on air, demo, nice. And then for the region, you actually need to choose. And this one's very important because we said you can put your storage and compute separate, but they have to be within same region, okay? Within same region. So in that case, you can leverage the petabit per second bisection bandwidth. So let's say I will have AWS Office 1, okay, that's nice. And then for the zone, doesn't matter, you just choose one of them. All right, so now you have the cluster mode. For today, I'll just use the standard, and for the master node, that's nice. I'll just use the default ones, and then this is a disk size. Oh, be aware that this size actually not just because of the size, but also actually going to affect what's the I/O throughput as well. Okay, so just a little bit remind, when you choose the size, it's not about how much data you store, but also like what's the throughput. I/O sometimes it's one of the difficulties when you actually need the performance. All right, so that's something you do, and then here's the worker nodes. All right, so here this is the type, and then I'm going to have 2. All right, that's good. So far it's all good. And then now I'm going to have this option here. This is a component gateway. So this is actually one thing's nice and easy because now you will have the web interface as a default, and then now you can easily to connecting to all those GUI systems in your cluster. And let's go with something advanced as well. There's a nice chance I can show a demo here. So, because now today we wanted to processing some data. Recommendation, I don't need to connect to the internet. So I will have a internal IP only cluster. That means I don't need internet because I have my data, I have my computing. Why do I need the internet, right? So internal IPs. So done, let's create a cluster. All right, so create. So now we're actually going to go for a coffee to wait for my cluster. Of course not, right? So now we will going to do something, which is we are going to send a job to that cluster, but this one is still running, don't worry. Let's go for the job first. Oh, by the way, I think at this moment, the question just pop out in our platform, so please take some time. But I'll say, focus on my demo first, and then later on, you go for the questions, all right? And then we will coming back for those answers. So this is the job, of course, and then let's submit some job. All right, so I totally believe that thing which is my cluster, is kind of ready. So what we're going to do today, we just do a very simple one, kind of like a mock. So we calculate something easily, which is pi. All right, so pi, and then I'm going to look for my cluster. Oh, this one, we are not running in global region. We're actually running in Asia Southeast 1. All right, so now you see the cluster is ready. Wow, that's fast. And then now we are going to do a Spark. And then here is my main class. If you want to do similar things, you can easily just go and check the GitHub later on. Okay, so just focus on what I'm doing here. And I'll get 1,000. And then I'll get my file, which is actually in the cluster already. All right, so the job files. All right, so now things are ready, and then now submit. So at the same time, this job will be created, and then it's actually submitted to it. It's on that cluster, and it's a Spark, and in the region of Asia Southeast 1. And by the way, that's just coming back to the cluster here. So this is the cluster, very nicely. It is running already, and there's 2 nodes. You see how fast it is. So that's what I said. Right now, starting from now on, you don't need a long-running cluster, because anytime you need a cluster, it takes so small amount of time that you can easily just get a cluster ready and then go for anything. All right, so for this one, I just wanted to show you that we do have a nice interface here, which is a web interface that you can always easily to go for. For example, you want to see the MapReduce job history or maybe the young application timeline. So if you click on it, yes, this is actually going to redirect. All right, so actually tells you that. Go for it. It takes a little bit of time to connect actually. This one, loading. You know what? Live demo, it's always the same. All right, at the same time, let me check the other one. Okay, so this is the one. Okay, and here you're actually able to see we are running a Spark Pi, and then this is the job. And this view is actually coming from our cluster. And you will ask me, hey, wait a minute. Okay, so this is a project, this is a cluster, and how am I going to connect? It's only internal APIs, right? Yes, it is only internal APIs. It is. And it's not connected to the internet, yes. But it's connected to Google service. So what exactly this one is, those 2 URLs, they are actually bring you to our Google services, and then we will make sure who are you, and then we will check and then make sure that yes, you are the authorized users, and then you'll be able to get in, and then we help you to use our Google service, go into it, and then link to your internal cluster, which is only having the private IPs. All right, so coming back to our job. So let's see the one we have, Pi. Click on it. Yes, great. So now we actually get the answer. So you see, this is nice and easy. And then at this point, things are done. So what we can do, pretty simple. Click on it and then delete it, and then boom. Bye-bye, my cluster, goodbye, and then now you save all the money because now no longer cluster there, no more consumptions, and then you pay only when you use. All right, so this is a quick demo, so let's move on. So we said, yes, on-prem data center. That's the common things that you have the cluster there to wait and running something, and then you might have some job you wanted to run, and then you might have HDFS, which is the Hadoop distributed file system you wanted to run and to store the data. So scenario number 1, we said you might have job 1, job 2, which is consume 100% of your resource. Then when you actually start need to run something, for example, job 3, to analyzing some data or maybe some ad hoc queries, then what do you do? Existing cluster, limited amount of resource, so you need to wait. Scenario number 2. Yes, you have job 1 and then 2, 3, 4, you don't actually have them. So you only consume 50%. Basically, you just waste 50% of your resource. So now you see, under provision, over provision is just super common here on Prime. Because I mean, you have an existing kind of like a resource there, and then you need to babysit the utilizations. So we will say, yes, this one will make it so easy because it's flexible. You only get a cluster when you need it, and then that's nice because every single job for one cluster, and then that means every single job you can customize not the job to fit the cluster, but actually customize the cluster fit your job. How nice it is, right? So that will just make sense, and then that will even make your security even easier because no longer sharing cluster with different teams or different users because you get your own cluster when you need it. And most of the time, you don't get the cluster, okay? Most of the time, zero cluster. Only when you need to run, when you have your data ready, when you have your processing ready, then that's the time you start to have a cluster there. And then start running. Once you're done, you finish the cluster. Boom, that's nice. All right, so actually how to turn down those clusters, you can do automatically or you can schedule it to do the deletions. So we have several options, and I suggest, again, go to the documents because we have more ways to do. And then here we said, oh, maybe some of the cluster we do need to resize because we need some change for our job. Or now the data is a little bit bigger, it's a little bit more. So we need the cluster get a little bit bigger. So what we do? Instead of just manually do that, if you want to, we also have auto scalings. So this one's in beta, and this one provides you some flexible capabilities. And this can be based on the yarn matrix. So if you don't know what is a yarn, it is okay. So just go and Google search, you will know it from maybe Wikipedia or some other place. But basically, in short, that's a resource management tools in Hadoop systems. All right, so you can use the resource management tools. They're having those metrics and using those metrics to support your auto scaling. That's nice. And then that can easily choose auto scale based on your policies. So even now, we are able to utilize with those PVM, which is preemptible virtual machines. That's just extremely nice because now give you some financial benefits because this one will significantly reduce the cost for those fault tolerant workload. Because this one, preemptible VM, if you heard about it before, nice. If you don't, what is that? Preemptible VM only costs you 20% of the price of those regular VMs. And they work exactly the same. They work exactly the same. But when you get preemptible VMs, it's not guaranteed they will be there in your project all the time. Because this one is like you get a discount, but there's a pros and cons. So you get the financial discount, but then we will going to take them away when we need it. Okay? So that means it's interruptible. But here in Dataproc, what we do, pretty simple. Dataproc actually help you to taking care of that. We actually help you to taking care of the join of those preemptible VMs and then the leave of the preemptible VM because you have no control when to leave, right? So this is kind of the case. And here we're taking care. So you just use it. And then when you're lucky, you get all the preemptible VM and then it's nice and cheap and then you get more nodes, then you'll be able to finish your job faster and save some more budget, right? So a little bit recap. Google Cloud Platforms enable on-demand scalings, yes. And then for here, if you do on Prime, yes, you have to deal with that by yourself. Under provision, over provisioned. Or here, you can choose Cloud Dataproc. I'll say if you do have some existing Hadoop cluster, of course, you have the resource, use it. But then once you need to scale, you might think of maybe to bring something here. Why not, right? Cloud Dataproc, easily just get it, nicely, try it on. Once you finish, boom, finish the cluster and that's done. That's nice. All right, so for the storage here, I will say instead of have them in HDFS, no, it's not the case. You actually keep them in cloud storage because to pull data from cloud storage to the Dataproc, it's easy because we have the bisection bandwidth, petabit per second network. So network, it won't be the case. It won't be the bottleneck here, okay? So So Google Data Center Network speed enables the separation of the compute and the storage, and this is the by extension bandwidth, so you can easily just get the data, and this is only here at Google. Okay, so of the cluster storage is a gateway to efficiency. So of course, you are going to keep your data somewhere else outside of cluster, so you can always shut down your clusters. And then a little bit recap. The separation of storage and computing power enable efficient resource allocation, so that enable the serverless, because the data proc here is actually serverless, and that one, you don't need to have a long running cluster. You just get the cluster when you need it. And most of the time, where is your data? Outside of the cluster. Yes, exactly, outside of the clusters. All right, so what is data proc? How to, without cluster management, lift and shift existing those workload with the big data open sources, and then you can easily connect to Google Cloud Storage to separate the storage and compute, and you can easily to resize and even leverage preemptible VM. I mean, seriously, if you're going to use data proc, I seriously recommend preemptible VMs, okay? And the best practice is like 50-50. On demand, which is the original price one, you go for the number that's still able to finish your job in time. And then you get exactly the same numbers. So when you're lucky, you'll be able to get double the number, and then you will get the job finished faster. But at the same time, you save some cost. Okay, so when you're, maybe sometimes we are more like full, a lot of users using the resource, then you are not going to get a preemptible VM, but still have the on-demand to taking care of everything. All right, so once the recommendations are calculated, where are we going to store them? So for example, you can store the rating user inventory in a relational database. For example, Cloud SQL is one of them. Okay, so if your data, yes, if you need transaction, if you have a relatively small amount of data, then Cloud SQL is the one. Or you can go for Cloud Spanner if you need horizontally scale, or if you need some millisecond latencies, then Cloud Bigtable will be one of them to go for as well. Or maybe BigQuery. But I mean, if you're actually going for recommendation, yes, you need to taking care of those requests coming from the user, so that'll be a response. So I'll say maybe not BigQuery, because BigQuery itself is more like the ad hoc query kind of things. All right, so Cloud SQL is full managed relational database. Very familiar because that one might be a MySQL in it, or a Postgres, or a SQL Server in beta that you can choose. And very flexible pricings. We manage a lot of things like the backup, the connections, the replications, and even very fast for the connections. Of course, you know, bisection bandwidth network within our region, within our data center. And of course, still the IAM, which is the Google security ways for you to taking care of that. All right, so now we finished this one. Let's go for the other one, which is predicting visitor purchase using BigQuery ML. So BigQuery, have a little bit introducing. I mean, seriously, I kind of believe a lot of people heard about BigQuery, because this one, you know what? The first time I met BigQuery, seriously, I met BigQuery like a long time ago. That was in 2010. Wow, that's 10 years already. And at the time, it is like what we show you here. It's a petabyte scale, full managed data warehouse. It's serverless. It's flexible for the pricing. The data encryption is all taken care of. And even you can deal with some geolocation kind of data. And then it's very easy for you to do BI and AI. All right, and the typical kind of like a data warehouse architecture is like a whole bunch of different kind of data source coming from streaming, coming from batch, all do a little bit pre-processing, because you might have some message which is unstructured data or semi-structured data. Once they're structured, then boom, everything in BigQuery. And anything else, for ETL, you need to do more, or ELT, you need to do more. It's all able to do here in BigQuery. And then you can connect to all the kind of tool you use it today, which is all kind of BI tool, or even Google Spreadsheet, or even Cloud Data Labs. So BigQuery, basically there's two services in one. I'll say those two. Fast SQL query engine. That one is nice. We'll see. And then the other one is the managed storage for the data set. So how does BigQuery work? Basically, it is two things under the scene. You have the query engine, you have the storage, and it's separation of storage and compute. What's the reason why we separate the storage and compute again? What's the reason? Because the coupled system scales better. Again, as a data engineer, always keep in mind, scaling. Make things able to scale and do things in a scalable ways. So we store the data in a separate storage system that's under the scene closest, very similar, exactly the same kind of behind technology as cloud storage. And then we have the query system here as well. Oh, by the way, the QA is actually going to disappear shortly, so answer your questions right now. All right, so BigQuery, we have two services in one, and then now what about the managed one, which is the storage? Okay, so the managed storage here, you can actually have a whole bunch of different kind of format into it, which is into that managed storage, and then we have our own formats to actually keep your data, to make it easy for our query engine to deal with. Yes, we have that. Or there's another way that we kind of believe, yes, that might be the case, because sometimes you just want to keep the original data format in use for some other tool. For example, the data proc we set. But you still wanted to use a BigQuery to analyze them. Then what about this one? You can just directly read those data from the data source, for example, from cloud storage, and then analyze them in BigQuery. Wow, that's nice. That means you don't need to put your data in BigQuery, but you're still using BigQuery as a tool to analyze them. All right, so before we move on to that, let's do a quick demo for that. All right, so here now we have a BigQuery. Okay, where's my BigQuery? Okay, this one. All right, and then let me just do a little bit cheating here to get the demo. I've done it before. All right, I love this one. Let's check this one. All right, so good. So this is the 10 billion row data set. Okay, this is the Wikipedia data. And then let's just jump into what is that. We have some year, month, date, that kind of things, the language and views and the title, of course. Let's get a preview. What is that? Of course, I mean, it's a Wikipedia. Everyone knows what is that. So you have the title, you have the views, you have the language. And then just a little bit detail. This one, the size is around like a 700 gigabyte. Oh, very small. And then the number of rows is just 10 billion. Not that big. Okay. So what we're going to do here, pretty simple. We wanted to check which language actually mention Google most of the time here in Wikipedia. And then for this one, what you have to do, pretty simple. Yes, everything here you can understand because it's standard SQL. And the only thing you need to do is write that SQL, having your data ready, and do the run. And then I just have a sip of my water because I'm thirsty, and then I just get my result. Oh my God. Sorry again for the word, but yeah, I love my God. So 7 seconds right there, and then boom, you get the result. 10 billion rows, everyone. Is that small? Yeah, I kind of believe that's the kind of size just about to break your database. All right, so here you are easily to do that. So now you get amazed. So let's coming back. What else you can do? This one, machine learnings. So when you talk about AI and ML things, you might think of those kind of like smart replies, but most of the time it's actually that kind of things. It's those kind of things in the structured data, and then you are actually going to process them. And then what do you do? Oh, you might want to do some predictions and then to fill some columns that you don't know the answers. All right, so we said predict customer lifetime values with a machine learning model, for examples. So we said this one. Let's predict the lifetime value of an e-commerce customers. Okay, so for example, we have a shop, which is a Google merchandise shop. So that one, actually, we have a lot of data. So we actually using our own Google Ads, which is Google advertisement. We have something called Google Analytics that give you a whole bunch of data. And then these are some of the data that we actually shows you that we have a lot of those aggregated kind of metrics. And then for every single of those rows basically means something, which is some of the observation, or we'll say the row of the data. And in this case, for machine learning, yes, that's raw data. And what we are trying to predict for is the label. So for example, we wanted to predict the lifetime revenues for those different customers. Okay, so that might be some of the numbers, and then we might have done before already. So this is nice because now we have some examples to tell us that that kind of customer having that kind of behavior before, and then that's the values. And then the label could also be a discrete class of a customer like a high value. For example, we just put them instead of a continuous number, but we put them into categories, say, oh, this one is high potential, this one is high value. Yes, that kind of things you can do as well. And then for all the rest, we will say these will be the feature columns for you to actually able to maybe to show you that it's a high value customer. So we said those are the potential feature columns. So what if I don't know where a new customer will fit? Because for example, a new customer comes in and you're still not able to calculate those lifetime values for them. So you do want it to, maybe based on your experience, then you will be able to do some calculations, right? So I would say this is the one that you wanted to do the prediction at the end. And then if you do have a mathematical functions or you have some kind of your own model, you might have the kind of weights about what kinds of column actually going to affect your results. So this is a very simple kind of case that you have some known data, which is examples to help you to taking care with some future data. So if you wanted to do that, you actually need all those things like a label, like a feature, get a model, get the type, do a training, having the weight, do evaluation, and to do the predictions. And then, okay, I've got data. What model should I use? And for that, to answer, you can easily use this chart. Choose the right model type for your structured data use case. If you're going for anything like, oh, I want to forecast a number, that's a continuous number, go with the linear regression, or maybe I just want to have a recommend of something, then maybe, oh, there's a matrix factorizations, all right? So different kind of things, you go for different kind of models. So this one's easy. So then, what do? You want a model, yes. And then you have some data in BigQuery, okay. And then you just take those data and then start to think about what are those nice features. And then you start to build your model. You choose a model, you start to do the training, you do the evaluation using maybe TensorFlow, and which is a nice open source, of course, but spend so much time on evaluation and then even might not get the result at the end. So what about this one? Because you just see that BigQuery can do something super amazing. It's super powerful that you can easily to process something. I mean, the demo I've done actually shows you that you don't need to define how much data you have. You don't need to tell them how complex is your query. You don't need to tell us how much computing power you need. You just click that button. Everything will be taken care for you. So why don't you just use BigQuery to do machine learnings? You have the data ready in BigQuery, and then you can easily just use some function to create. Of course, you define what's the model. You create and train, and then when we do the training, for example, if you need something like a hyperparameter tunings, we taking care of that. If you need a learning rate, you can define all we taking care of that for you. And then you can easily to do the evaluation. Once you okay with that, then you go for the predictions. Okay, so behind the scenes, we do a lot of things for you, automatically tune a lot of auto splittings, and then even some advanced ones, all right? So basically, the machine learning here in BigQuery, we give you a whole bunch of things. You use the standard SQL, you can do the classifications, and then with those norm ML, yeah, inspect model weights and adjust the hyperparameters too. All right. So let's see this one, a quick demo as well. So back to this one, let me just do a save one as well. So we will get the data. So get the data for the module. So this one, it is the one we have mentioned it, okay? So I'm not going to explain too much detail here. We're just going to have the bounds, the time on site, and then they are going to buy or not. So just click on it. We will get the results soon. Okay, so this is the kind of data we're going to do. This is our label. They will buy, in return, and visit, yes or no. Okay, so this is the training data, and then this is all the features. So how are we going to just do the training? Pretty simple. Create a model. And here, this is the way. Pretty simple. You define the model and you define everything. And then once you click on the bottom, then you will get something. But of course, today it's hard because that will take several minutes. So let's check on this one. All right, let me scroll it down and then let me get my model here, which is in e-commerce. And then boom, this is the one. Okay, so this is the model I trained already. This take around like 5 minutes if you click that one, but we don't have 5 minutes here. So this is the one. We have done some things for you, and then this is for line search, great. And then this is the training. You will actually get the charts here, so you're actually going to know what happens in it. And then the evaluations we told you, it's like this. Okay, so you actually get a lot of metrics to let you know how things works. Then if you want to, you can train it again. And then the schema, of course, will tell you what's the feature, what's the label, and then you can easily to use that and give the model to someone else to use them. All right, so now it's just about the time that we coming back to our live questions because you guys do the answer and then let's see what's the answer. So what model should you use if I want to predict the sales number of next month? I mean, still remember we have that chart, right? I hope you guys do the screenshot. Okay, if you don't, doesn't matter. It's okay. All right, you're still able to get the video recordings. So what's the answer here? Because sales number, it's a continuous values. So that will be regression, and this is forecasting. Yes, okay, so I kind of believe, yeah, most of the people are actually correct. Sorry, this time it's not all of the above because, yeah, sorry, I do a little bit tricky things here. You still have that option, but that one is not the answer. Sorry, I get you. All right, so we have one more questions. What model should you use if I want to predict if a user will buy or not buy? Oh, this is exactly the one that we actually done the demo in BigQuery ML, right? I mean, I've done the demo a little bit fast. I mean, don't worry if you kind of like a little bit lost or you miss some part, it's okay. You'll get the video. You can check that. Okay, so what is that? It's buy or not buy. So it's in category. So I'll say that's classifications, okay? So that's the classifications. If you done it correctly, thanks, good, very nice. If you have still a little bit doubt about that, no worry. Later on, you can check the videos. Oh, by the way, before we finish this module, so short introductions to show you around the GCP platforms, and great for those of you who are new to GCP. And yeah, so we have some great story about Abu Quater, a young visionary with a passion for innovation in the field of healthcare and computing. And oh, that's actually something. It's a nice video later on. I'm actually going to show you because that's something really amazed. And then he actually utilized AI to build some data-driven healthcare solutions with a vision of brightening first world healthcare to third-party countries, and really inspired. And I hope you guys will actually enjoy that later. So again, thank you for joining us digital events, and please stay tuned for the next module.